Hello everyone, welcome to our next mock test, that is mock test 3. Today we are going to discuss 20 MCQ questions, along with that 5 numerical type, along with we are going to discuss about the tips and tricks. Okay, let's get started with the first question. Which of the following will show highest ionic mobility in aqueous solution? By the way, I am attaching the PDF in the description box. This is mock test 3. You can click on mock test 3 to get downloaded. There you have the solutions as well. Okay, so you can also check out mock test 1 and 2. Try to attempt those questions first of all and then check the answer. I know you guys are practicing questions. You are going to ace the examination with more and more marks. Let's discuss more about the questions now. Okay, so talking about highest ionic mobility. Highest ionic mobility in aqueous solution. The options are lithium, sodium, potassium and cesium. Those are in the same row. Alkali earth metals. Cesium has the largest ionic size because as we are moving down, atomic size increases, right? Ionic or atomic size increases. Although the ionic mobility decreases with increase in ionic size, right? So what will be the right answer? Cesium has the least degree of hydration because we have told that is aqueous solution. Due to its low charge density, it is having the least degree of hydration. It results, cesium becomes highest ionic mobility in aqueous solution among these four. Correct? Then we are moving on to the next question. Here we have the questions of easy to difficult. Difficult is a large number of questions here we have, but still we have easy question. Because basically this is the pattern of JEE Main. And the major product obtained when phenol reacts with bromine water. Bromine water. There are two types of reactions with phenol. One is bromine with CS2 and another one is bromine water. So without any catalyst, just bromine water is reacting means it is an electrophilic substitution occurs, and what is the product? It gives ortho and para position occupied because phenol, the OH group, that is electron donating in nature, is undergoing electrophilic substitution. So the answer becomes 2, 4, 6 tribromophenol. In the presence of catalyst means it will give orthobromophenol and parabromophenol separately. But simply aqueous bromine water, not aqueous, bromine water, then that will lead to give 2, 4, 6 tribromophenol, which will look like this. Okay. Radius of the first Bohr orbit of hydrogen atom is 0.53 angstrom. Okay, the radius of the first Bohr orbit of lithium 2+. Anyway, the number of electrons here is also 1. So, how to calculate it? Very simple. So, you just need to do R is equal to 0.53 divided by, what is the atomic number of lithium? 3. So, divided by 3, which will give you 0.167 angstrom. They are given in angstrom, asking it in angstroms. Let's say this question, consider the reaction which is 2SO2 plus O2 gives 2SO3, contact process. If the equilibrium of concentrations of SO2, O2 and SO3 are 0.2, 0.1 and 0.4, the value of equilibrium constant Kc is. So Kc, which is equal to, we very well know, the concentration of the product raised to the power of its molar coefficients divided by the reactants. Is it? So SO3, which is 0.4 square, then SO2 0.2 square into 0.1, which becomes 0.16 divided by 4 into 0.1, that is 0.004, which makes 40 as our answer. Here the question is asked to find out the Kp. Kp, once again you can just simply apply the formula, that is partial pressures of NH3 and then partial pressure of N2 into partial pressure of H2. Is it? So just apply the values, you will be ended up with the answer 2. In the following reaction sequence, benzene gives X and X gives Y, Y gives Z. Where X is C6H5NO2 and Y is C6H5NH2. C is benzene diazonium chloride. So reaction to convert Y to Z, that means amines to benzene diazonium chloride. What is this reaction? Very simple diazotation reaction. By the way, Sandmeyer, which is dealing with copper and HCl, which will give chlorobenzene, bromobenzene, and Gattermann, same as that, but only the catalyst changes. Hoffman bromamide, it is from amides to amines. First order reaction, 75% of complete in 60 minutes. The time required for 87.5% completion will be. So here you can see for 75% it takes 60 minutes. So T, which is equal to, we know the formula, 2.303 divided by K into log of A naught by A. Isn't it? So at 75% of completion, A by A naught, which is equal to 25. So T 75%, we are just substituting the values, 1 by 0.5, which will give you the value log 4 and then T75, that is 60 minutes. So you can just 2.303 divided by K log 4. So K, which is equal to 203 by 3 divided by 60 into log 4. So the overall K value becomes 0.0231 per minute. So we just need to keep this as a K value and substitute it for 87.5%. Isn't it? We have to find the time from that. So I'm going to substitute it T 87.5, which is equal to 3 divided by 0.023, 10 log of, here A naught is 1 and then A will become remaining 0.125. So 1 by 0.125, that is log 8. So in total, by solving this, you will be ended up with 90 minutes. Or else what you can do is, you can just try it out with how many half-life this is. Okay, that is also one way of solving this. Which of the following statements is incorrect about the D block elements? They form colored compounds. True. They show variable oxidation states. True. They have high melting and boiling points. Their compounds are always paramagnetic. They won't be always paramagnetic. They can be of diamagnetic also. Paramagnetic, which are having your unpaired electrons. Dia, which is having, which are not having any unpaired electrons. Then for the complex ion, FeCN6 4 minus, the correct statement is. So what is the oxidation state? That is +2. So this can't be the answer, this can't be the answer. Remaining A and B, the complex is paramagnetic or diamagnetic, that we have to find. So here you can see Fe2+, which is after argon 3D6,4 is 0. So cyanide is a strong field ligand. What that will do? This will do the para. If you are taking CFT or VVT, anything works here. So just it will pair up the electrons so that it is diamagnetic, not paramagnetic, because of the strong field cyanide ligand. Then structure below represents the structure is this. What is the structure? This is furon. It is an aromatic heterocyclic compound. Which of the following sequence is correct? Benzene gives A gives B gives C. So once again same type, but still what is C? Which is CH3CONH C6H5. The percentage yield in this step, in each step, is 60%, 50% and 80%. 60, 50 and 80%. Okay. The overall percentage yield of C from benzene is approximately. So you can see from benzene to A formation, that is 60. So nitrobenzene to aniline, that is 50, and aniline to finally CH3CO and H3. Then the acylation process happens, that gives 80%. So just calculate the overall yield. Overall yield can be calculated by multiplying a yield of the single step. So here we are calculating 0.60 into 0.50 into 0.80. So in total that will become 6.6 into 0.5 into 0.8, it is 0.24. That is 24%. So this is 24%. Option A is the right answer to this question. Then for a reaction A gives products. The rate doubles when the concentration of A increases by 4 times. So the order of the reaction is, in reaction kinetics, we have saw this type of tricks, like how we can calculate it. So which is a simple one. If A concentration of the A increases by 4 times, then the rate increases by 2 times, right? So rate which is proportional to our concentration of A, isn't it? So we're just going to substitute the values. So the rate doubles. So what will happen? So I'm just having it 2 equal to 4 to the power n, because concentration increases by 4 times. So log 2, which is equal to n log 4, right? Okay. Then So log 2, which is n log 2 to the power 2, and then overall by solving it you will get n is equal to 0.5. Okay. Then which of the following compounds can undergo Cannizzaro reaction? Cannizzaro reaction means it needs a aldehyde without an alpha hydrogen, right? Acetaldehyde, benzaldehyde, propionaldehyde, acetone. So among these four, which is not having alpha hydrogen? Which one? That is none other than benzaldehyde. This question, central atom in PCl5 in gaseous and PCl5 in solid. So what is the hybridization? So what is big thing about this question is that you have to know what is the difference in gaseous and solid state. Gaseous state you can easily observe. The hybridization would be sp3d. We very well know how to calculate that. And PCl5, it will exist as in two ionic form, that is PCl4 plus and PCl6 minus. Among this, PCl4 plus is sp3 hybridized and PCl6 minus, that is sp3d2 hybridization. So answer to this question becomes sp3d and sp3. 3 isomeric alcohols with the molecular formula C4H10O on oxidation with acidified K2Cr2O7 gives. So C4H10O, that can exhibit, what are those isomerism? Either I can write it as a primary alcohol with a straight chain, that will give you aldehyde, right? That is one way. The another way of writing it is, I can write it in the secondary, like second position substituted, 2-butanol, right? So in that case, that will give you ketones. And the another way of writing it is, you can write it in the substituted one, like this. Once again, this is also comes under primary alcohol. This will give you aldehyde. And is there any other way? You can write it as like this, CH3, 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 OH. So this is tertiary type. So where upon oxidation it is resistant to oxidation. If you are increasing the temperature, that will lead to form a alkene rather than forming any carbonyl compound. So answer to this question is that two aldehyde formation and one ketone formation. Electronegativity of carbon, nitrogen and oxygen and fluorine increases in the order. So we know that electronegativity increases if we are moving left to right in the period and decreases down the group. So in the second period, the order follows. Fluorine, that is most electronegative, so obviously this is not an answer. And then comes oxygen. So this will not become our answer. Then comes nitrogen and then carbon. So option A is the right answer. Moving on to the numerical type. The half-life of the first order reaction is 60 minutes. The fraction of the reactant that remains after 180 minutes we have to find. So they have given that is first order reaction. So just doing with the formula, T half is equal to 0.693 divided by K. So K becomes 0.693 divided by T half, that is 60 minutes. So K half here becomes 0.0115. Correct? So minute inverse, that is our K. So what they are asking is the fraction of the reactant. So A by A naught, that is equal to e to the power minus kt, right? So we are going to just substitute the values over here. K value which is found, that is 0.0115 into 180 minutes. 115 into 180 minutes. So which will give you E is minus 2.079. For calculating it, so the final value becomes 0.125. So into 10 to the power minus 3, then that will become 125 is our answer. pH of 0.001 molar of HCl solution at 25 degrees Celsius. It is very simple. Just count the decimal point. There is no very straightforward question. There is no confusion at all. Just take, they are asking pH, yes. They have given HCl only. HCl, that is having only one hydrogen in it, right? Not H2SO4. So count the decimal points. Count the digits after the decimal point, that is 3. So pH will also become 3. If you are doing by the formula also, minus log base 10 H plus, then you need to take the log value of 0.001. This will become log of 1 into 10 to the power minus 3. 3 will become first. Log 10, which is equal to 1. So the answer becomes 3. Or else the easy way you can do, check for the question and then put the digits after the decimal point. The number of stereoisomers possible for the compound 2,3 dichloro-pentane. So pentane 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 2,3 dichloropentane. So they are asking for the stereoisomers. So how many chiral centers are here? This is one chiral center and this becomes one chiral center, right? 2 chiral centers, which becomes 2 to the power n. We have already given the formulas where we have to use which formula to find out the stereoisomers, right? So 2 to the power 2, that is n is number of chiral centers. So total 4. So 2 pairs of enantiomers and 2 pairs of diastereomers are present. 25 ml of 0.1 molar H2SO4 solution is mixed with 75 ml of 0.2 molar NaOH solution. The pH of the resultant solution is. So you can go about the amount of calculating or amount of H2SO4, which is 0.1 molar into 25 ml, that is 0.025, which will become 0.0025 moles. Then amount of H plus ions, which is equal to the same 0.0025 moles. But here I have H2SO4. So amount of H plus in H2SO4, that is 2 into 0.0025, that becomes 0.005 moles. Similarly, you have to find it for NaOH. Then 0.2 into 75 ml, that is 0.075, which becomes 0.015 moles, which is equal to our OH minus count. Here we have only one OH, so you need not to multiply with anything. So once it is mixed, which will be higher? As you can see, the moles which will be higher. So obviously NaOH will be higher. So X is NaOH. That is 0.15 minus, after the neutralization reaction, the excess of NaOH will be 0.01 moles. Correct. So the concentration of NaOH will be 0.1 mole divided by the total quantity. Here we have total 100 mLs. So I'm just calculating it, the concentration of NaOH. So 0.01 moles divided by 0.1 liter. So that will become 0.1 molar. It's our NaOH concentration. Then we have to do the POH. Base 10 concentration of OH minus. Then you need to substitute 10 to the power minus 1, it will become, so 1. POH is 1. So pH will become 14 minus POH. Is it? So 14 minus 1, 30. So answer to this question becomes 30. Boiling point of benzene is 80.1. When 6.5 grams of non-volatile solute is dissolved in 100 grams of benzene, the boiling point rises to 81.4. The molecular weight of the solute is. They are asking for the elevation in boiling point. What is the formula? Just a simple one. Delta Tb is equal to ableoscopic constant Kb into M. So M here represents the molality, right? Molarity of the solution. So just I'm taking M as a one side and remaining those terms goes to the another side. What is the difference from 80.1 to 81.4? So the difference is 1.3. Kb value they have given, that is 2.53. So 1.3 divided by 2.53 will become 0.5138 mole per kilogram. That is our molality. What they are asking is molecular weight of the solute. So from molality, what is that? Which is moles of solute per kilogram of solvent. So we want moles of solute, so that mole, which is nothing but given terms by the molecular mass, is it? So moles, I'm taking one side, so M into kilogram of solvent. We are just going to substitute the M value 0.5138 into 100 grams of benzene is added. So that will become 0.1 kilogram. So this becomes 0.0513. So the molecular weight is given weight by the molecular weight, is it? So molecular weight becomes given weight by moles. So which is mass, that is 6.5 grams of non-volatile solute. Moles, that is 0.05, which will give you the answer 126.5 approx. So that becomes, or 127 will also work. So that becomes the answer to this question. So please check out the PDF for all those solutions and questions. We'll meet in the next session. Just let me know how many question papers you would require.